Hello friends, welcome to ETAP's learning training series. Now so far we have discussed about modeling of the ground floor, first floor, second floor, balcony, roof level. After that we have also defining the support conditions. We have also modeled the staircase, waste slab, landing, and we have also shown some advanced modeling options. Now continue in our existing project. In this video we will defining the load pattern or load types. So now from this video, couple of videos, 3 to 4 videos, we will defining all the load patterns, all the load combinations in our existing building, and then after that we will do the analysis, and then after we will do the designs of this building, so that you have complete practical idea that how any residential building or any commercial building can be designed in ETAPS in such a manner. So we will go to the define and we will go to the load patterns. So here as you can see there are two loads already there. So dead load, and here the type of the load that you can be defined. So obviously dead load has a dead type, that is self weight of the load, and here is the very most important self weight multiplier. If you will be put this value as a 1, then ETAPS will be calculate, or ETAPS will be take self weight of the structure while doing the analysis. And if you will be put the value 0, then ETAPS will not be takes any load from this point of view. You have to define that load manually. So let us we will discuss how these things will be work in ETAPS practically. So first of all we will define some of the loads so that we can have the idea. So obviously dead load, and we will keep the value 1. Then after live load, and in the live load, let's say right now I am delete this live load because of we will define the live load in a two other manners. Let us say first of all we have to defining the name. So let us say, so in ETAPS first of all you will define the name, wall load, time, the types will be dead load, and let us say I will be keep this self weight multiplier 0, so that we will define the wall load manually. After defining all the parameters from here, then you will click on add new load. So as you can see wall load, dead load, and self weight multiplier 0 has been added. Similarly let us say we will be add another load, that is parapet load. Again the type will be dead load, multiplier will be 0, add new load. Similarly the next load will be floor finish. Here we are applying the self weight multiplier 0, that means we have to define this load manually in the structure. Again add new load. Then after we will defining live load, less than or equal to 3. So I will be explain you why I had used this method less than equal to 3, because of at some portion of the structure we will define the live load less than equal to 3, and at some other structure the live load will be greater than 3. Then if you had divided the load in such a manner so that you can easily apply. So now in the case of live load, as you can see by mistake I had choose the type that is dead. So I will be click on live and click on modify load. So like this manner you can also modify as well. Let us say live load, and I will be choose greater than 3 and make sure the type is live and click on add new load. Similarly earthquake load, and earthquake load I will be specified in a 2 direction. So EQ in X direction, and type of the load earthquake will be seismic load, and the multiplier is 0 and click on add new load. And similarly I will be add EQ in Y direction, seismic, multiplier 0. Auto lateral load I will be keep right now none, but you can also keep as per your design standard. So for the earthquake seismic load IS 1893 2002 code has been used. and latest is IS 1893 2016. So that one code you can also use if you are doing Indian type of designing. And last but not least, roof load, and the type will be live load or roof live. It will be not matter, both are the same. Multiplier is 0 and click on add a new load and click on OK. So this is how you can defining the load pattern in the ETABS. Okay, so after defining the load types, now we have to defining one more thing, that is diaphragm. Now what is diaphragm? Diaphragm means it will be act as a whole structure as a one. So let us say if I will be go to the ground floor plan view. So our structure whole this ground floor plan view will be act as a one single unit. So let us say if I will be apply any lateral load on this direction, then it will not be happen like that. This beam will be deflect more than this beam, or this beam will be deflect more or less than this beam, like that. So we have to consider, or we have to convert whole this structure, all the elements on this plan view will be considered as a one single unit. So we have to define the diaphragm. So the purpose of defining the diaphragm means the whatever the elements, whatever the structure elements are available on that floor view, to convert as a one single unit. So how to define the diaphragm? So we will go to the define, and here there is option of diaphragm. So right now there is a one diaphragm is already there. Now how many diaphragms that we will be required? We will be required ground floor, first floor, second floor and roof. So we will be required 4 diaphragms. So we will click on add new diaphragm, name let us say D2, and rigidity it should be rigid. And again add new diaphragm D3, and again add new diaphragm D4. Obviously you can also specify the name, let us say ground floor, first floor, second floor, roof, like that. So let us say if I will click on D4, click on modify show, and you can rename from here as well. So I will be click OK, and again click on OK. So I will be go to the ground floor plan view. If you will be not in ground floor plan view, click on set plan view and click on ground floor and click on OK. So this is our ground floor plan view. So first of all I will be select everything, and after selecting everything I will be go to the assign, joint, and here there is option of diaphragm. So I will be click on diaphragm, and I will be click on D1 and click on apply. So as you can see in D1 ground floor plan, there is a one D1 structure, D1 diaphragm has been created. Similarly, what I will do, I will be go to the move up in the list, again move up until I will be reached to the first floor, and again select each and every element and click on D2 apply. So as you can see diaphragm has been created. Similarly, again I will be move up second floor, select everything, D3 apply, and again I will be go to the move up, select everything, and D4 and click on apply. Okay, and you can also check the diaphragm by going to the different views. So as you can see here there is a ground floor diaphragm, here there is a first floor diaphragm, second floor, and roof level, and click on OK in order to define the diaphragm as well. So we have defined the load pattern, we have defined the diaphragm. Now next step is we have to define the mass source. Now why we have to define the mass source? So I will be explain this thing practically. If you will be follow IS 1893 part 1 2002, that is criteria for earthquake resistance design of structure, and in that if you will be go to the table number 8. So in the table number 8, as you can see, percentage of imposed load to be considered during the seismic weight calculation. This is very most important. During the earthquake load, during the seismic weight, what is the imposed load, that means live load you have to consider, and up to which limit the live load is there, and what is the imposed load that you have to be considered. So that is the things that we have to be defined. So that's why I have defined the live load greater than or up to 3 and live load less than 3. So if your live load is less than or equal to 3, then you have to define the live load intensity, that is 25. So you have to define 0.25. So you can consider 25% of the live load. And if your live load is greater than 3, then you have to consider 50. So that means you have to consider 50% of your live load. So that's why we have to follow this code, and obviously in your different country you can follow your different code. So if I will be go to the define, and if I will be go to the mass source, so I will be go to the define, and here there is options of mass source. So here there is a one mass source, so I will be click on modify show mass source, and here there is a name that you can specify. Let us say I will be keep default name, and element self mass, that is turn off, and specify load patterns. If I will be turn on this option, so as you can see here load patterns has been turned on. So now as whatever the load patterns we have defined just recently, all the load patterns is available at here. So we will define dead load, wall load, parapet, live floor finish, and live load up to 3 and greater than 3. We will not define earthquake load, and we will not define roof load. Why? Because of during the earthquake we will assume that roof load will be 0, because of there will be no any person or there will be no any live load during the earthquake. So we will go to the dead load, and multiplier should be 1, and we will click on add. Similarly we will go to the wall load, multiplier 1, parapet wall, multiplier 1, floor finish 1, and make sure live load less than or equal to 3, multiplier should be 0.25, because of as per the code we have to consider only 25%. So we will click on add, and again we will go to the live load greater than 3, 0.50, because of here 50% is given. So we will click on 0.50, and we will click on add, and we will click on OK, and we will click on OK. So one more thing that you will define, that is you cannot one more thing that you have to be noticed, that we are not adding any earthquake load in x direction, any y direction, and we are not adding roof live load multiplier as a mass source, because of during the earthquake we are assuming that there is no live load on the roof. So we will simply click on OK, and we will simply click on OK.